so we're going to look at going from vertex to standard form and back and forth. So a couple of things, remember that vertex is the top or maximum point of the parabola, and then maximum point or minimum point. So standard form, we've kind of looked at it just kind of briefly. So standard form is y equals ax squared plus bx plus c. So like you saw your trinomials, those were in standard form. And so that's what we're going to go to or away from. The transformations, remember that we had, if you remember when we shift right or left or up or down, the vertex for the quadratic parent function is 0, 0. So any shifting right or left is going to change that vertex from 0, 0. And so that is going to be what our vertex form looks like. So our transformations, will remember we have y equals plus or minus a times x plus or minus h squared plus or minus, write that the same way, plus or minus k. And then the vertex form, so when we have our vertex form, we're going to have y equals a times x minus h squared plus k. So remember that what was inside of my parentheses, remember it didn't follow the rules. So that's that negative sign that's right there in front of the h. So that's what makes it not follow the rules, that darn negative. So then so that's a vertex form where h and k is my vertex. So that's easy to spot. I can look at a function in vertex form and say, that's a vertex. So that's the whole point of it. And then the axis of symmetry, remember, is that vertical line where the parabola is symmetrical. And so when we look at this, I kind of call it the mirror line, because when I look at a table of a quadratic, I can see it start to mirroring each other. So, but also the key thing here, remember that in our vertex, okay, that axis symmetry went straight through it, and that was that x value of my vertex. So the axis symmetry is going to be x equals negative b over 2 times a. So where does b and a come from? Well, they come from my standard form way up here. Okay, so I'm going to take the middle term, negative b, over 2 times a. That's going to give me the axis of symmetry straight down the middle. Now, what's really cool about that is that I could then plug in that value to find the y value from a standard form to find the vertex. So that's why you need to know that. We'll point there. All right, so the first thing that we're going to do is we're going to identify the vertex, and then we're going to write this in standard form. So this form here, I can look and see that this is in vertex form, okay? So let's just write those. I'm going to write these over here so we kind of remember. Y equals ax squared plus bx plus c. Remember, that is standard form, and then vertex form is a times x minus h squared plus k. So those signs do matter, so it's a big key thing. So the vertex here, so if I were to write plus 3, so notice it's not minus 3, but if I wrote minus negative 3, that would be the same thing as plus 3. So therefore, my vertex is going to be at negative 3, so h comes first. So the vertex is h comma k, and then negative 10. So I'm going to keep the sign with the k, because remember, k is positive. So since it's a negative there. So my vertex is at negative 310. So now here comes the hard part. The hard part is going to be writing this in standard form. So what we're going to do here is we're going to multiply out x plus 3 squared. You cannot just square x and square 3, because x plus 3 squared means I'm going to take x plus 3 times x plus 3. When I do that, I got to use FOIL. So I'm going to come over here. So I have x plus 3 times x plus 3. So I'm going to square this piece right here. I'm coming over here. So I'm going to do first x times x, which is x squared. Outside, x times 3, which is 3x. Inside, which is 3x. And then the last, which is going to be 3 times 3, which is 9. And this makes 6x. So after identifying the vertex, I'm going to come down here, write my multiplied form out. So I have r of x is going to be equal to x squared plus 6x plus 9 minus 10. Well, notice that I still have some like terms I can get together, so I'm going to go ahead and get those two together. So you'll see that 9 and negative 10 are like terms. They don't have a variable with them, so those two are my like terms. So going to standard form, r of x is equal to x squared plus 6x minus 1. That's 9 minus 10. And then this is my standard form. So I wanted you to identify the vertex first. Remember, that's easy. I can just look at the function. Boom, that's my vertex. And then go to standard form. That's going to be super helpful looking at the vertex for the next problem. All right, so we're going to identify the vertex and then write it in vertex form. That's what we have to do, is be able to write this in vertex form. So what we're going to do here is that we are going to find that axis symmetry. So x is going to be equal to negative b over 2 times a. So negative b, which is negative 8, divided by 2 times 1. So I can plug that into my calculator exactly as you see it, and I'm going to get a positive 4. And so therefore, I'm going to plug in. So I'm doing this to find the x value of my vertex. So then I can write it into vertex form. So therefore, I'm going to have h of positive 4. So that's going to be 4 squared minus 8 times 4 plus 17. And that is going to give me a positive 1. So h of 4, so when x is 4, y is 1. So my vertex is going to be at 4, 1. Then I can plug it into my vertex form. So to write this into vertex form, I'm going to have h of x is going to be equal to x minus 4 squared. There's no a here, and then plus 1. So I don't have to worry about any kind of a or anything like that. So this is vertex form. So I had to identify the vertex first, then write it in vertex form. That's kind of going back and forth there. All right, so let's look at this last one. It says identify the vertex again and write it in standard form for the quadratic function. So here we're going to be able to just identify the vertex. So remember, that's this number and this number. So remember that just like in the first example, I would have, it has a plus 6, which is really like a minus negative 6. So negative 6 is my h. So remember, hk is my vertex. And so h is going to be negative 6 and k is negative 2. So therefore, this is my vertex. So isn't that nice to be able, aha, I know the vertex just by looking at it. Pretty cool. But here's the hard part. Now we have to go back and we have to write this in standard form. So, yeah. What I need to do is I am going to square here. I'm going to square x plus 6 over here to the side here. So x plus 6 squared is like x plus 6 times x plus 6, which means I have to FOIL. So I have x times x, which is x squared, and x times 6, which is 6x. And then I have 6 times x, which is 6x, and 6 times 6, which is 36. That's a lot of 6's. So then I get these two together. Remember my middle terms, and that makes 12x. And so therefore, I'm going to have 3 times x squared plus 12x plus 36, and then minus 2. So this one requires just one more step because I have that 3 that's out in front. That doesn't affect the vertex, but it is going to affect my function here. So I'm going to have to distribute here. This 3 is going to be multiplied here, here, and here. So I have 3x squared plus 36x plus 108. And then minus 2. So just like before, when I have my like terms, remember these two do not have a variable with them. So I have 3x squared plus 36x plus 106. So a little bit more involved there when you have a coefficient out in front, that a, but not as bad. Being able to have, especially I didn't have the vertex. So I will be able, if you want me to, I can show you how to find the vertex in your calculator. So you don't have to find the vertex manually like on example 2, but you're more than welcome to. And that's helpful to be able to find that axis symmetry as well. So remember, so let's kind of walk through these steps. So if it's in vertex form, you're going to standard form, you're going to have to square out your what's inside the parentheses, and then get together your like terms. And then so that's pretty much it. It's just the squaring part is going to require FOIL. So just keep that in mind. And then you're going to, if you're going to go from standard form to vertex form, you're going to have to find the vertex, and then you're going to, or axis symmetry, then plug the x value for axis symmetry in to find the y. And then you're going to be able to then write it into your standard form. So just given that vertex. So that's a good practice for you to be able to get there, is just given a vertex, what is the standard form? And so back and forth there. All right, so that's it for all of these parabolas, and we're looking at all the graphs and all that good stuff, all this new vocabulary with the transformations, vertex, kind of reviewed domain and range, and now vertex form with the H's and the K's and all of that. So we're just trying to wrap that all together.